In this example, we're being asked to multiply two polynomials. The first, the one on the left here, 3v plus 3y minus 4, has three terms in it, three additive terms, so we call it a trinomial. The second, the polynomial we're multiplying it by, 4v minus y, has two terms, and so we call it a binomial. So here we're multiplying a trinomial on the left times a binomial on the right, and we want to simplify what we got. So what's our strategy going to be? It's actually the same strategy as the previous example that we did, to distribute multiplication over addition. The only thing that makes this different is that both of our factors, both of the things that we're multiplying by one another here, have multiple additive terms in them. And so the rule of thumb that the distributive property of multiplication over addition gives us is that every term of every factor has to be multiplied by every term of the other factor. So here's the strategy, step by step. Again, we're going to start by locating the operation. Here I'm going to phrase that as locating what are the terms in this problem and what are the factors, what are the things which are being added to one another, and what are the things that are being multiplied by one another in this problem. Once we know where the terms and the factors are, we're going to distribute. Specifically, we're going to distribute the multiplication that's happening to each additive term. So every term from the first expression will get multiplied by every term from the second expression. Once we've done that, our parentheses will all go away, and then it's just a matter of simplifying the way that we did before by combining powers and combining like terms. So let's start by locating the terms and the factors. Starting, according to the order of operations, with the factors, we can ask, what really is being multiplied in this problem? And what's most important that's being multiplied in this problem are the two polynomials in the sets of parentheses. The polynomial on the left, 3v plus 3y minus 4, and the polynomial on the right, 4v minus y. So those two quantities are being multiplied. There's a little multiplication symbol in between these sets of parentheses that's implicit in the way we use algebraic notation. And so I'm going to refer to that first polynomial as the first factor in this problem, and the second polynomial as the second factor in this problem. Calling them factors just means that what we're doing with them is multiplying them by one another. Meanwhile, each of those factors has terms of its own. Terms refer to things which are being added or subtracted. So inside of the first factor, I have three terms, 3v, 3y, and 4, or negative 4, if you prefer to see it that way. And in the second factor, I have two terms, 4v and y, or minus y, depending on your perspective. So our expression here has two factors in it, and each of the factors has multiple terms in it. The first factor has three terms, the second factor has two terms. So we're really multiplying, again, a trinomial by a binomial. Let me rewrite it a little bit larger. Now we can distribute. And what distribution means in this example is that every term of that first factor needs to be multiplied by every term of that second factor. So what do we expect to happen? That 3v from the first factor has to multiply both the 4v and the minus y from the second factor. The 3y from the first factor has to multiply the 4v and the minus y from the second factor. And the negative 4 from the first factor has to multiply the 4v and the minus y from the second factor. So what do we expect to happen? Because we started with three terms in the first factor and two terms in the second factor, if we multiply everything from the first by everything from the second, we should end up with a total of 3 times 2, or 6, terms after we've done all of our multiplying. This is a really convenient observation because it'll help to remind you if you happen to forget a term later on. So when we do all this multiplication, we expect we're going to have 6 terms before we simplify. So let's go one at a time. Starting with the first term from the first factor multiplied by the first term from the second factor, 3v times 4v. I'm not going to simplify that yet. I'm just going to write it down and put a little check mark next to the line that indicates we've taken care of that product. The first term from the first multiplied by the second term from the second will give me 3v times minus y, which I'm going to write as minus 3v times y, just moving the minus out to the front. Next, we'll multiply the 3y from the first factor by the 4v from the second factor. We'll multiply the 3y from the first factor by the minus y from the second factor. So now I've taken care of everything that the 3y needs to multiply. Finally, the negative 4 from the first factor multiplied by the 4v from the second factor to give us minus 4 times 4v, moving the minus out to the front again. And then the negative 4 from the first factor multiplied by the minus y from the second factor actually gives us, in this example, a pair of minuses, minus 4y, which before we go any further, let's change that into a plus so that we don't end up with any sign errors later on down the line. And now looking back on everything that we do indeed have 6 terms. We multiplied every one of the first factors 3 terms by every one of the second factors 2 terms. And so we know we've got everything. Another way that I like to visualize the work that we're doing here to make sure that we remember to get everything is to use a little table. This is kind of another nifty little way of accounting for all the terms that you're working with. And the way it works is we'll write each one of the terms in the first factor along the top row of this table, and each one of the terms of the second factor down the first column of this table. And then inside each of the squares of the table, we'll write down the products of what's on its row and its column. So the 3v multiplied by the 4v is going to give us, well, 12 times v times v. If we simplify that by adding the exponents on those v's, we'll end up with v squared. After all, that's what v times v really means, right, is v squared. And in our table, that's what we get when we multiply the 3v and the 4v. So 12v squared is going to be in that little box. We're just keeping track of what we're doing. It's a different accounting method, if you like. The minus 3v times y, we can't really do anything to simplify that, so we're just going to write it as minus 3vy. Where did that come from? It came from the 3v times the minus y inside of our table. So we'll fill in one more of those boxes. Next, we had the 3y times 4v. Moving the 3 and the 4 together, we end up with a 12vy. Where did that come from? It came from the 3y times the 4v, so we'll put that in the table over there as well. Then we had minus 3y times y, which we can rewrite as minus 3y squared. Y times y, after all, is y squared. That came from that entry in the table, minus 3y squared. Then we have minus 4 times 4v, which we can rewrite as minus 16v. And we had plus 4y, which there's really nothing we can do with. So now we've simplified each one of the individual terms, which make up our product, and accounted for them in the table to make sure that we remember that we've gotten them all, and we can see from the table where they came from, which is why I kind of like the table. It's a nifty little way of keeping track. And so the last question is, now that we've combined all the powers that we can combine, are there any like terms that we can stick together to make this expression simpler, to rewrite this expression with fewer additions than it is currently being written? And the answer is yes. That there happens to be a pair of like terms right there, the 3vy and the 12vy that are present in this expression. Because the variable factors are identical, both variable factors are v times y, we can combine those terms, they're like terms, by combining their coefficients. Negative 3 plus 12 will give me positive 9. So when I combine those like terms, negative 3y plus 12vy is going to give me 9vy. But that's the only pair of like terms in this problem, meaning that everything else has to be written as is. And that completely simplifies this product of a trinomial by a binomial. So what did we do? We knew we had to multiply. It was stated for us in the beginning in the problem. But even if it wasn't stated, we could tell that the quantities we were multiplying together, there was no operation in between those sets of parentheses. And so implicitly, we're multiplying the trinomial on the left by the binomial on the right. How do we do it? Well, we know that the distributive property of multiplication over addition requires us to multiply every term of that first factor, all 3 of the terms of the trinomial, by every term of that second factor, both of the terms of the binomial. And so we have to expect that in total, we're going to have multiplications happening. When we account for every one of those 6 multiplications, we end up with this expression that has 6 terms in it. 12v squared minus 3vy plus 12vy minus 3y squared minus 16v plus 4y. Once all that multiplication dust has settled, it's a matter of combining any like terms that are present in that final answer, of which there were 2, the negative 3vy plus the 12vy. Combining those like terms by adding their coefficients to be a positive 9 gives us the finished expression for the product of these 2 polynomials.